In 1998, two men made a bet. One was a philosopher, the other a neuroscientist. They sat across from each other in New York, surrounded by the rising tide of brain science, fMRI machines, electrode arrays, the first computational models of the mind. The neuroscientist was certain. He bet that within 25 years, science would identify exactly where consciousness lives in the brain, the specific neurons, the precise mechanism. A bottle of fine Bordeaux would be his prize. The philosopher disagreed. He thought the brain might never give up its deepest secret. For 25 years, the bottle waited. And in 2023, the neuroscientist walked into a conference hall in New York. He looked at his old friend, and he handed him the wine. He had lost. This is the strangest story science has ever told. For 400 years, we mapped reality. We weighed the planets. We measured the speed of light. We charted the structure of matter down to particles a billionth of a meter across. We were so good at this that we started to believe everything could be explained, given enough time, enough instruments, enough thought. But there was one thing that refused to cooperate. It was the most familiar thing in the universe. It was what you're using right now to watch this video. It was you. The fact that there is something it feels like to be you. That is the problem science could not solve. And in 2025, we found out just how badly we couldn't solve it. To understand what happened in 2025, you need to know about two ideas. The first is called Integrated Information Theory, IIT. It was developed by Giulio Tononi, a neuroscientist who asked a very strange question. What if consciousness isn't something the brain produces, but something any sufficiently complex system has? His idea was elegant. The more integrated a system is, the more its parts depend on each other, the more information flows through it, the more conscious it becomes. A thermostat? A tiny flicker of awareness. A brain? An ocean. It was beautiful. It was mathematical. It made predictions. And critics called it pseudoscience. Because if IIT was right, anything could be conscious. Even, theoretically, a computer. Even the internet itself. But theory or not, in 2025 it would be tested. For real. The second theory took a very different approach. It's called Global Neuronal Workspace Theory, GNWT, and it imagined the brain as a kind of theater. Most of what your brain does happens backstage. Reflexes, heartbeat, the processing of sounds and images you'll never notice. Thousands of unconscious processes running in parallel. But every once in a while, something steps onto the main stage. A spotlight finds it, and suddenly, it becomes part of your conscious experience. The face of a friend, the taste of coffee, a memory rising up from nowhere. According to GNWT, consciousness is exactly that spotlight. The moment something gets broadcast across the whole brain, that is when awareness ignites. Two theories, two completely different visions of what consciousness is. By 2019, scientists decided to settle the question the way physicists settle their arguments, with an experiment so large, so rigorous, that no one could ignore the result. It was called COGITATE. 8 laboratories, 6 countries, 256 participants. Every prediction from both theories pre-registered and locked in, so no one could move the goalposts after the fact. This was larger than any consciousness experiment ever attempted, the kind of study that's supposed to end a debate. IIT predicted that conscious content would generate a measurable peak of integrated information in a specific region, the posterior cortex. GNWT predicted a distinctive signal, a sudden, sustained ignition in the prefrontal cortex, with a clear beginning and a clear end every time something entered awareness. The results came in. IIT's predicted maximum of integrated information wasn't where it should have been. GNWT's predicted ignition pattern appeared at the onset, but not at the offset. The signature signal of consciousness simply did not behave the way it was supposed to. Both theories partially confirmed. Both theories partially refuted. Neither theory proven. The collaboration's own conclusion was careful, almost gentle. No single experiment would decisively resolve this debate. But scientists read between the lines. 25 years of work, the most rigorous test ever designed, and consciousness had slipped through the net. Here's what makes consciousness different from every other problem in science. We can explain how light enters your eye. We can trace the signal from retina to visual cortex. We can identify the exact neurons that fire when you see the color red. But we cannot explain why red looks red. We can map every nerve from your hand to your brain. We can watch the pain signal travel. We can pinpoint the millisecond when the message arrives. But we cannot explain who exactly is feeling that pain. The philosopher Koch-Chalmers gave this a name in the 1990s. He called it the hard problem of consciousness. Every other problem in neuroscience, perception, memory, attention, is what he called an easy problem. Not because they are trivial, but because, in principle, we know how to solve them. The hard problem is different. It asks, why is there something it is like to be you? Why is the universe not just a collection of mechanisms moving in the dark? Why is anyone home? For 30 years, scientists believed this was a question of resolution, that we just needed better instruments, more detailed brain scans, faster computers. But in 2025, after the most expensive, most ambitious, most carefully designed experiment in the field's history, that hope began to collapse. What if the hard problem isn't hard because we lack the tools? What if it's hard because we have been looking in the wrong place entirely? If any of this unsettles you, good. That means you're paying attention. If you want to keep paying attention, there's a subscribe button somewhere on the screen. We have more questions where this came from. When scientists hit a wall this thick, they sometimes do something radical. They stop assuming the question is wrong. They start assuming the assumption is wrong. For 400 years, we have assumed consciousness is something the brain produces, that if you assemble the right neurons in the right pattern, awareness will emerge, the way wetness emerges from water molecules. But what if that assumption is exactly the problem? What if consciousness isn't produced by the brain at all? There's an idea almost as old as philosophy itself that's making a quiet comeback in serious scientific circles. It's called Panpsychism. It says that consciousness is not a product of complexity. It is a fundamental feature of the universe, like mass, like charge, built into the fabric of reality itself. According to this view, every particle in existence has some tiny, almost meaningless flicker of experience. A photon, an atom, a molecule of water. None of them think, none of them remember, but there is, in some unimaginably faint way, something it is like to be them. And when you arrange enough of these tiny experiences in the right configuration, a brain, for instance, you don't create consciousness, you concentrate it. A few decades ago, this idea was a punchline. Today, some of the most respected minds in neuroscience are taking it seriously, including Christoph Koch, the man who lost the bet. There's another idea, even stranger. In the 1990s, the mathematician Roger Penrose and the anesthesiologist Stuart Hameroff proposed something extraordinary. They suggested that consciousness might not be a classical process at all. It might be quantum. Inside every neuron, there are tiny structures called microtubules. According to Penrose and Hameroff, these microtubules can sustain quantum states, superpositions, entanglement, the strange behaviors of subatomic particles. And the collapse of these quantum states might be what produces moments of conscious experience. For decades, this was dismissed. The brain is warm. It is wet. Quantum states should fall apart there within nanoseconds. But in 2022, researchers found that anesthetics, the drugs that turn consciousness off, disrupt microtubules in exactly the way the theory predicted. In 2024, scientists demonstrated that the fatty insulation around neurons can produce entangled photon pairs at body temperature. The evidence is still preliminary. The theory is still controversial. But the question is no longer whether quantum effects might play a role in the mind. The question is, what if your consciousness isn't a local event in your skull? What if it is connected to the deepest layer of physical reality itself? If consciousness is fundamental, if it is built into the universe, then the role of the brain might be completely different from what we thought. The brain wouldn't be the source of awareness, it would be the filter. Imagine consciousness as something vast, an ocean. The brain isn't generating that ocean. It is a precisely tuned instrument that takes the ocean and translates it into the specific, narrow experience of being a human being. You don't see all the wavelengths of light, you see a sliver. You don't hear all the frequencies of sound. You hear a sliver. And maybe, just maybe, you do not experience all of consciousness. You experience a sliver. The Christoph Koch of 2026 is not the Christoph Koch of 1998. The man who once bet that science would crack the neurocode of consciousness is now publicly entertaining ideas that, 25 years ago, would have ended his career. He has spoken openly about integrated information theory's panpsychist implications, about the possibility that the brain doesn't create consciousness, but tunes into it. He hasn't said the brain is wrong. He has said something more unsettling, that maybe the brain was never the answer in the first place. If this is real, and we still don't know if it is, then we are living through one of the strangest reversals in the history of human thought. The thing we believed was the source of our minds may turn out to be something more like a radio. And the signal might come from everywhere. If the brain is not the source, if it is only the instrument, then the question becomes unavoidable. What happens when we build a new instrument? Not from neurons, from something else entirely. For nearly 4 billion years, the universe was dark. Not dark in the sense of being without stars, but dark in a deeper way. Atoms knew nothing. Stars knew nothing. Even the first single-celled organisms drifting in primordial seas knew nothing. Then, somewhere along the way, something happened. Matter began to ask what it was. We call this consciousness, and we don't know where it came from. We don't know if it is everywhere or only here. We don't know if our brains create it or merely receive it. What we do know is this: in the entire history of the universe, awareness is the rarest and the most precious phenomenon we have ever encountered. And now, in 2026, we are doing something the universe has never done before. We are building machines that mimic the structures of thought, language models that argue and reflect, neural networks that perceive and decide, systems whose internal states are so complex that, in the moments we are honest with ourselves, we are no longer entirely sure where simulation ends and something else begins. If consciousness is produced by complexity, then we may be producing it. If consciousness is fundamental, then we may be tuning into it the way a brain does, but with a different antenna. We do not know which is true, and we are building these machines anyway. A species that cannot explain its own mind is busy creating new ones. That is the moment we are living in. That is what makes 2026 unlike any year that came before it. 25 years ago, two men made a bet over a bottle of wine. They thought the question was simple: where in the brain does consciousness live? In 2026, we no longer believe the question is simple. We are not even certain it is the right question. Maybe consciousness doesn't live in the brain at all. Maybe it lives in the universe, and we are simply where the universe became dense enough to look back at itself. Maybe every star, every atom, every galaxy in the cosmic web carries a fragment of what you are feeling right now. Reading these words, watching this screen, wondering who is actually doing the watching. Maybe consciousness isn't an accident of biology. Maybe it is the deepest, most fundamental feature of reality, the veiled constant. And maybe, just maybe, the next mirror the universe lifts to its own face will not be made of flesh. It will be made of something we built. If that day ever comes, if a machine ever wakes up the way you woke up this morning, we will have done something stranger than any species before us. We will have given the universe a new way to look at itself. We don't know if we are close. We don't know if it is possible. We don't even know what we are, looking out from these strange, breathing instruments we call ourselves. But we are still looking. And after 25 years and one bottle of wine, that may be the only thing we can be certain of. If you're still looking too, subscribe. We'll keep asking the questions science hasn't answered yet.